Okay, how are we doing, Don? Okay. All right.
Okay.
You get the address.
Sounds good. Yeah, I got the dog board. That's I'm taking squared away for. That's on your computer. It should be sounding. We should be.
So yeah.
Just been on a meeting here.
Yeah.
Well, we're not sure we have the sound.
This sounds all, yeah. The question is whether people can hear. So if you sign in on your computer.
So definitely have something here.
Anyone at home? I think they will. Well, let me test the microphone. We can test the microphone.
Down or going to. Test, test, test. Hello. Hello.
See if you can hear us or not. Let me get this one going.
Eddie, put your mic on, let us know if you can hear you.
Well, no, she can't hear you from that. She could hear you from here. Or from here. This is the microphone now.
Oh, this is it now?
This is it, yeah. So let me put it here. Maybe it wasn't picking up.
And let us know if you can hear what's coming through and unmute yourself on Zoom. She was sick today, so she's not coming.
Yeah, I had a migraine most of the day, but I don't know.
It's not even fatigued yet.
I know. I know. And this is supposed to be spring break, right?
Kathy, can you hear us?
Yeah, because they have.
Let me tell you, this,
Comes on the first Tuesday of the month.
Okay, it needs to be pressed up.
He's on the visualization group.
Okay, Kathy, can you hear us now?
I can now. Yes, I can hear you. I couldn't get my mute off to tell you that I could hear you.
I just changed the audio inputs and outputs.
What'd you change it to?
Same as system.
Okay.
That's this.
Yep,
And then the Crestron.
whatever that is.
That's the whole system.
Okay, all right, good.
And can you hear us okay?
Ann, can you hear
So
us?
did you do that last night?
It just is.
Can't hear her.
Okay.
I was on a program. called
Oh, that's cool.
With.
It's just me coming in again.
Yep, I see you.
They brought the chickens. And Mike gave a talk about.
Right.
Talk about.
You're having issues with Zoom?
Oh, good. I can hear her over the system.
I can hear her. I couldn't hear Ann at all, but I can hear Kathy.
Yeah. So we're hearing them, do you want to hear them over the system the way I have it
That's
set?
fine.
Well, can you do it over Zoom and not in person so you don't get them sitting?
I think it's important that we actually get it.
You need any of my decks?
Nope, it's good. I'm gonna launch it now.
I think, we're okay.
All right, I got them on there.
Let me get it, let me launch it.
Right.
Let me launch it.
And I met him.
Right.
Down at, Sunspot. You know, the Sunspot,
I guess I'll go get sit down then.
one of the.
I think we're good. Thanks, Sue.
Yeah, no problem.
But-
Right, right. Keep the fluids and the ibuprofen on board.
To turn it back to the original.
Okay.
condition. So they opened it up.
Okay.
at, Socorro, it's one of the places. So, but anyway,
Yeah.
you know, everybody here should kind of know about that.
Oh, I hope this goes by quickly for you. That you feel better.
The other one,
Right? Uh-huh.
since they run.
Don, I think we're good. I think we're good.
Enough they
I can see the screen share if that's important.
You can see these screens? Good.
Yes.
Okay. Good, good. I want you to, because you'll get better faster. Mhm. That's so nice.
You have to turn this down.
Yeah.
Yeah, have that off, that sound off.
Yeah. Oh, yeah, there you go.
Well, the, on that, it says.
I think I had it.
In the Dale, lives in the coma. So some of those things you wonder.
Uh-huh.
Sometimes you wonder, you know, either AI or bad Chinese.
Before we start, there's cookies and drinks, and we have.
Well, they, rheumatology checks for a lot of things. Most important thing they do is get your list of symptoms and see, does any of them make sense for the rheumatologic illnesses that are out there?
Turn off
And so that's,
the mic.
Which one?
One of the Dons.
Sounds great.
So this mic is on the wall that, turn that one off while we're doing the meeting, and then when
Oh.
Don starts, you can use that.
Okay,
I think that'll work.
Kathy, say something.
I'm saying something right now.
We can't hear you now.
No, I can hear you.
We can't hear you now.
So do we have to put it on a different chipset or a different setting?
I don't know.
So the only thing you changed was to shut this off?
Yeah, well,
Oh, no, this is the one I sent to you. So go ahead and turn whatever you have on. I'll mute this one.
see what I did. I lowered the volume, I brought it back up.
I just muted this one. It was this one that was.
Oh. Kathy, say something now.
I'm saying something now.
We're not getting any sound.
What did you change?
I didn't change anything. Let me get back to Zoom.
The important thing is she hearing us.
You hear us, Kathy?
Can you hear me now?
We don't hear anything you're saying. Let me look in here.
We can hear, I can hear you.
Yeah, I didn't mute did you mute the?
I muted Ann because we're getting a lot of feedback.
And she's muted herself.
No, I did that because
Okay.
it's coming over the speaker. So that's the same, that's the same.
The only, I turned this on.
This is turned up.
This is just this mic here.
Right.
So that's what I thought it was probably.
Say something now, Kathy. Leave it on. Leave it
1,
on.
2, 3, testing.
She's talking. Put it back on.
Can you hear me?
It was on, we heard her. See, we heard her through that.
So it's on when it's green.
So it's on.
Oh, you turned that one on. Okay.
And when you hit that, it goes off. Say something now, Kathy.
Say it again.
There we go.
Okay,
That's the
Can you hear
room.
me?
This is this. So that's the one I was talking about turning.
okay, how about now, Kathy?
Okay, one more time.
Yep,
We can hear her.
we can hear.
So
Keep
what
the
was
volume up.
feeding back was,
Oh, with
so
the
when
mic.
Don goes to talk there,
Okay,
then you.
one more time, Kathy.
One more
Sing the
time,
song.
Kathy.
Sing the song. Sing us the Mickey and them Mouse song.
No, you don't want to hear me sing. I'll clear your room out.
We can just barely hear, it, but that's okay.
Out there, you can hear it much better. than
Okay.
in here.
All right, so you got the mic off,
I
okay.
have just that mic.
Just that is off, okay, so, and you can hear us okay, Kathy?
Yes, I can hear you fine.
All right, now
Now
we're
we hear
good.
you fine too.
All right,
Okay.
good. That was a problem. Well, last year we had a problem, so I think
yeah,
we're good now.
Believe me, I haven't had to.
No, just in time to,
Well, they're off.
the meeting.
Is that Bill O'Hara I see in the back?
What's that?
Is that Bill O'Hara I see in the back?
It's hard for me to hear you, but
She said, is that Bill O'Hara?
Okay, no, I see a white-haired gentleman in the back. I thought maybe it was Bill O'Hara.
Bill O'Hara's not here now.
Monday afternoon, I'm back.
As long as we're not.
But I don't know what's, see, I have this.
I have 3 computers.
Then you have
I have this sound off.
That's another.
How about the?
Let me look at, let me turn this mic off. Maybe that's,
It's like last minute.
I can't change it. I have the sound what we did.
Yes, it's really nice.
All right, turn this sound off.
That's much better.
That's better. Okay, that's what it was. It was this mic was picking it up.
See if Kathy can hear Kathy.
I can hear you. Can you hear me?
All right, I think we're good. It was this computer.
Right.
So-
All right, are you hearing an echo on your end, Kathy?
Not at all.
Okay, fantastic.
I don't think I'll be able to sit with you tonight. All right, so you can start the meeting, I need to present.
Okay, first of all, everybody who's here, it's great to see all these faces here at the meeting. It's amazing what happens when a little warm weather shows up. You can show up here too. And I don't know if you guys are like me, but last night I went outside and took a look at the thin new crescent moon with Jupiter just hanging like a ball right overhead. Earthshine was kicking off the rest of the moon. It was nothing short of gorgeous. By the time I ran in, got my macro camera set up and all that, it was down. Got frustrated yet again, but still, it was nice to be out, it was nice to be observing, and it just feels great. The warm weather, I think, is hopefully energize all of us to get out and do some observing. We've got a busy meeting tonight. First thing first, and certainly one of my favorite things as club president is to recognize the people who have done so much work and get official recognition from the Astronomical League. Nice guy, that one. Oh, we're doing that.
Whichever you want, you can do the AL.
Let's do the AL.
Let's get me out of the way.
And Don needs no introduction to any of us, and I don't think that anybody in this club ever has worn so many hats and done so much for this organization. And now,
You wouldn't be saying that if we didn't have this work.
yeah, I'm saying a lot of executive, a lot of more other work. The point is that Don has done an incredible amount of work over here, and he has done so much outreach. It has been amazing to us all. He's inspired me certainly to get out of my astrophotography observatory, get out and show people the night sky, as I know he's done for countless other club members. And the AL has now awarded Don with the master level outreach.
Take some pictures for the newsletter.
Picture of this and a picture of that one.
Ready?
Yeah. Hold on.
Let's get it straight down there, guys. Ready?
Okay.
You say when.
Now.
Okay.
Okay,
That's bigger.
and this is perhaps more impressive. When you get the master anything, they give you a big plaque. instead of a little tiny-
That's actually, that was from last year's outcome. And that's really a entirely separate thing from that.
But, there you go.
That's just a special award because I'm the next guy. I asked them why they gave that to me, and it's because I did all the work on the website for the outcome and because I'm on the Global Star Party once a month, so that's what that's for.
So Don, congratulations, and it's well, well.
Do you want to do that first again?
However, Don's not the only one getting awards. There are many people in this room, not everybody, but there are other people in this room who've also been involved in outreach. And it is time to recognize you folks.
Okay, here's the list.
Switch out, let's go through this. John is not here.
Here you have Susan's here.
Dennis O'Leary.
Here are these two.
That's Dennis.
So we're gonna get everybody down here. We got that on stage. Here's the pin, and we'll get someone to take a picture.
Bruce Ruggieri. Our program chair.
These pins are really cool. You can simulate your own eclipse with these. You know. The stage, we need everyone on the stage.
The man with the Takahashi Chris Strong.
Yeah.
Emily Scott.
Yes.
It's all you.
My Barbara's out.
With a friend.
I can't go. Sure, that's great.
Okay.
It's like it was hard.
Barb Nab. All right. Warren Katie.
He is
Not here. Okay. Mike Hopper.
He's not.
Not here. Randy Rainville.
Yep.
Front and center, please. Kathy is not here.
Kathy,
She is
get
here.
one. Where was you?
Kathy, you get one.
Get one.
And that's it.
You and May.
Get back up here.
Chris Murphy.
Here and May.
In front of everyone.
I don't think this is.
No, John and Chris are not here.
John and Chris are not here.
Rich is not here.
Rich is not here.
Oh, there you go. Okay, there it is.
There's yours. Really there something.
Yeah. Mike couldn't.
Mike Manningley is not here. Roger and Linda Kennedy,
They're here.
please.
Oh, he is here. John Miller should come up because he already got his though.
Yeah, I did already get mine.
He should be up here.
Oh.
We're gonna send this picture to tonight's guy.
Thank you so much.
Oh,
You did on?
I can't give you what you're.
you have your pin too. You just got to look pretty up there.
All right, that'll work.
Gary Hudson,
Gary's not
not here. Oh, we're giving this guy an award. Okay, great. Pete Keller. Go on, Pete. On the left hand side. Man who never misses an event as long as he's not rained out. Then he can't back to
Like that.
You too.
When you do that, I would
Even
have thought.
worse.
And here's one for Ann.
But Ann Miller is definitely further due. And Alyssa, so.
So we need to have someone take a picture. I got
You
mine
all need
already.
to, just get a little more cozy there.
This.
Yeah.
Yes.
I'll turn it back.
All right, seize it.
Cheese it.
All right, let me get one more. There we go.
All right.
Anybody who needs equal classes, take a couple with you, you know, everyone should have some, right?
Great.
Got here.
They're like growing on me.
Take empty shirt. All right, we have one more calendar left to whoever wants one.
Seriously, it's got beautiful pictures everywhere.
I'd like to take it.
Bruce? Yeah. Bruce wants a calendar.
Red green. I have.
Mark, do you have enough?
Yeah.
No color, but even black.
You be, class. That's all I have. That's all I have. My daily box, but class.
Have some. Must be mine.
Something
I
like-
have, I have a box.
Okay. All right, yeah. That's all I have.
I'm just dressing in my.
I do.
Because some of the box outside the house.
Okay.
Oh, take it.
Yeah.
Have a menu. Okay,
Yeah, same one.
and this is a great night for me. I would next like to ask Bruce Ruggieri to come up and share with all of us what he shared with the exec committee earlier this week about our scholarship fund. Bruce, take it away.
So everyone, you know about our society scholarship for 2 Westchester students. We started this campaign to fundraise funds. This is the second year, month and a half ago. As of tonight, we've raised $3,850, which is amazing. About 4 days ago, I sent off a check to the Westchester University Foundation. They administer the funds. And right now, the process of reviewing candidates is ongoing, and by mid-May, we should have our 2 awardees. But this is really good, folks. I mean, not only do we meet this goal, now we have $800+ for next year. I mean, the whole idea here is that continuity, have this be sustainable. So I really can't thank you enough for supporting generosity. Really, thank you to everyone.
And Bruce is being a little modest, but he came up with this idea, saw it through with the board at the university, and has just stayed on top of this. Bruce, thank you so much. This really, I mean, not like we haven't had a tight relationship with Westchester University for a long time. This further enhances that relationship. Thanks, Bruce. And with that, I think we should probably,
We were going to talk a little bit about outreach initially, and then remind people
Okay.
if they want to join after the meeting or stay on, but we wanted to do right before.
Don, you want to come up and
Sure.
go to your slide for me? Get that slide, go on. I started this one, but we'll do the other one first.
I think the thought was to do the slides at the end, right?
Whatever's.
Yes,
best for
let's
you.
do the slide to the end since it's already loaded.
Just basically, the thought is, we want to try to basically maximize our outreach efforts and make them as meaningful for the people coming as possible. And so anyone who's really interested in outreach, afterwards, we'd like to show you a few slides with ideas, get ideas from you, and see what do we agree as a group we want to. Does that make sense?
absolutely. So stick around. Tuck that under your thinking caps while we go through the meeting, and we'll put it in there. And with that, let's get started with the meeting. Bruce, take it away.
So everyone, I don't think Don Miller, Don number 2, sorry.
Let's keep hoping to make on for one sometime.
Well, you know the Avis commercial, when you're number 2, you gotta try hard.
Well, I gotta try hard. Don, I can't compete with that.
But you can try.
I guess.
So Don obviously is not just a society member, he's a NASA Solar System ambassador. In meeting announcements, I've given a little bio about his career in the pharmaceutical industry, a number of the things that he's done, like amazing places he's gone and things he's done all over the world. And he's had a lifelong interest in astronomy. So Don was going to give us a two-part talk. Okay, and the probability of life, intelligent life in the universe, and it was part one and part two. Part one was in January, and for those of you who remember, we had a bad storm, power outage, cut short. So today, Don's agreed to kind of give a recapitulation of it, of part one and launch into part two. And with that, leave it to Don.
He told me I have all night, so hopefully we'll have time. Okay?
Breakfast is coming at 10.
We'll call it the Don Miller Messier Marathon.
You should see it. I was there at home in January. I had the thing, I was all speed up. We started, power went out completely, pulled up my cell phone, made a hotspot, tried to actually continue like that. The connectivity was so poor. My baud rate went around 60 megs per second to like 2. And so it was not gonna happen. So we got maximized those.
What are these slideshow?
We can slideshow right now, and
You did the light, Don?
yeah, I'll get them. They're over there, Don, if you want to pick out whatever one you want.
Normal is there. Let's see how intimate we can make it. It's pretty intimate.
So where you can still see up there.
Everybody good?
Yeah.
That works for me. Oh, yeah. Do you have a laser pointer on that one too?
It's the center button for the laser pointer.
Okay, perfect.
Right over there at the cat toy button,
And the advance is just the button here?
the right button.
The right button.
That should be it.
Okay.
All right, let me turn this so we have all
Oh, that'd be great. You can minimize that. So my first talk, as Bruce said, was really about the probability of life in the universe. And really thinking about how likely is it essentially that we're alone, is the question. This is something that mankind's been thinking about for eons. And
just, you know, the microphone for Zoom.
oh, it's over there?
is over there.
I can do that. All right, Kathy, you hearing me?
Yes, I can. Thank you.
All right, sorry. So basically, mankind's been thinking about this for a long time. Astronomers have been thinking about it for a long time as well, and there's lots and lots of published research and literature in this field. I've just given the surface in that first talk. So what I've done is, I'm not going to give you the full first part again. I'm basically just going to summarize what we talked about last time up to that point, and then I'm going to take it on from there. And then I've cut out a lot of stuff because I didn't want this to be a 2-hour marathon. So if there's questions you have, I'll try to answer them. If anything I say you don't understand or it's confusing, please stop me. And with that, I'll just start. So what we covered last time, there's no scientific consensus on the definition of life. When you think about what we're looking for, if you're looking for life in the universe and you think it's out there, how do you know when you see it? Searching, oh, sorry, I hit the wrong button, Don.
Go back, just go from the slide.
Just go back to slide
The
view.
mouse.
Right there, yeah, that's.
Okay, got it. Searching for technosignatures versus biosignatures. Remember, technosignatures is something that's not natural, and you're trying to look for this usually with radio astronomy, trying to find those signatures that, like you're listening for little green men, essentially what people were trying to do. Biosignatures, you're actually really looking for atmospheres. It's much harder. You're basically looking for exoplanets and looking for the signature in that atmosphere. But we're doing that work today. There's a few citizen science projects relating to SETI that I covered last time. No SETI signal to date after 50 plus years. And that was basically my point was, well, do we continue? You know, have we given it enough or have we not really done anything? And basically, when you look at the parameters of trying to, it's in radio astronomy, to say, I want to look at signal strength, position in the sky, I want to look at phase relationships, etc. One model I looked at was at least 9 to 11 dimensions. And so basically what the one author basically said, took the water in a hot tub, and that's how much we searched. You would compare that to the water in all the water on Earth, basically is how much you need to do to cover that many dimensions, possibilities of what you're looking for. So in reality, from a point of view of looking, we've only just begun. And I talked a little bit about the importance of modeling in science, really to set the stage for the modeling that was done in the past. So picking up where we left off last time. I just started touching on the Drake equation. I won't really, belabor it too much. Basically, the number of civilizations in our galaxy is equal to the star formation rate, fraction with planets, how, fraction that could actually potentially hold life with life. And then he was calculating the amount that basically intelligent life that could be communicating with us. He wasn't just saying microscopic life. He was looking for signals out in space. And remember, Drake came up with this from setting up a conference of the 12 people in the world who were interested in this in 1950, 60, I guess it was it 60 or 50, Roger? And I'm trying to remember the exact, it was 60. And so this was basically his agenda for the meeting, to talk about each of these parameters. And so, is that going too fast, or I did talk about that last time, I just wanted to put it back up again. So, you can do a lot of parameters here, and they did ranges on all these parameters, and there's a lot of assumptions here for like the star formation rate, how many planets could it be. At that time, they didn't know that there were any exoplanets. They figured there must be, but they actually had no data to say there were. So they did range of them. So you put the parameters in here, and these are just sort of mid-range numbers that were put in by that crew at the time. Number of civilizations in our galaxy would basically be L, which is the lifetime of a civilization. Okay, so how long is it intelligent enough to be producing technology that would put signals into space? Okay, and basically, if L was 10,000 years, so the civilization lasts for 10,000 years, you'd end up with 10. They actually did a range of parameters, so it went from as low as 10 up to 50 million potential ones. But when you think about what they did at the time, there's lots of unknowns, lots of assumptions. I'm not belittling what that group did. They were the state of the art in 1960. We've come a long way since. It's a great start, and it gives you a framework by which to contemplating this whole concept of, are we alone? And that framework has actually been echoed through the decades to today. Limitations Drake equation is really only estimating intelligent life, communicating life, okay? Only considers planets, not moons, okay? That wasn't a concept at the time. And there's many unknowns. And truthfully, some of them are still unknowns. And of course, the Fermi paradox. And I didn't really, I had to shorten my talk, so I'm not going to discuss the Fermi paradox. If anybody wants to talk about that in detail, we can do it later on. Okay. Basically, what the Fermi paradox says is, if the galaxy is so big and there's so many stars, why aren't they here already? It's an old galaxy. There should be here by now. And I can give you the whole history on that. So it's been a lot of time. So now it's time to update the Drake equation. Few key concepts, which I think this group will be very familiar with, is you have to have habitable zones. Really wasn't a concept at that time when Drake developed it. One circumstellar, and the other is galactic. So circumstellar, this is a classic plot here with different star types, with our sun being here, red dwarfs here, and then supergiants here. This is our solar system just for reference. But the blue band is the habitable zone. Remember, habitable zone is defined as liquid water. So if you're too close, it's going to be too hot. You're going to have steam, or you're going to lose all your water. If you're too far out, you're going to have ice, and then it wouldn't be possible either. So you can see the hotter the star, the more it moves out the habitable zone. Earth is in this plot placed right in the middle. Very debatable. A lot of people have argued that we're actually not in the center. We're in the front of this already. We probably have about 1 billion years before it gets too hot here. So this is a key concept when you're thinking about all the stars. How many are in the habitable zone for that star? And one of the conundrums is, well, how do you count red dwarfs? Because most stars in the sky, and you'll see, I'll give you more data in a few minutes, that talks about that most stars are red dwarfs. And the problem with red dwarfs are they're teeny, but they expose their nuclear core a lot, and they're very violent. So you could be radiating all the planets around them. So that's a big unknown today. And this concept can be extended to moons and termed circumplanetary rather than just circumstellar. One concept that was just started to be discussed last year was, stars change in age. So when hydrogens go to helium, it becomes more dense, the reaction goes faster, star gets hotter. So planets can shift their orbits due to interactions with other planets or bodies. If a planet's currently in a habitable zone, it may not have been there in the past, It may not be there in the future. You could even argue that the Earth, right now it's habitable, but in the distant past, we had no oxygen. So it wouldn't have been habitable. In the distant future, a billion years from now, it's going to be a cinder. So, it won't be habitable again. So the estimate by one astronomer is, 30 to 75% of planets could be belatedly habitable. Another confounding factor, not really factored into the other talks, but just to give you food for thought. The galactic habitable zone assumes basically you're too close to the galactic core, you're in problem. Because in the galactic core, stars are very close together. You've got a lot of violent reactions happening, supernova occurring. Radiation levels are thought to be very high. Essentially, it's thought that you basically have sterilized that whole zone. So the thinking is that this inner core is not habitable. And then metallicity, which in astronomy is any element that's greater than helium. Okay, you need metals. And you need metals for a lot of reasons. One, of course, is you need carbon, oxygen, phosphorus, the things that make life as we know it. But you also need uranium and other things that cause plate tectonics. They cause the formations of magnetic fields on planets to protect them. It's a very complicated subject, but I list some of them here, and we can talk more about that if people are interested. But metallicity, those metals are produced by stars living and dying. And the metallicity varies radially on the galaxy, as well as axially on the galaxy. So if you get too far from the plane of the galaxy, there's not enough metals. You get too far out, there's not enough metals. So essentially, this is us right here. This whole area, probably not enough metals for life, too much radiation for life. Okay, give you an idea. So rethinking the analysis of Drake. Let's look at two approaches. These are not by any means an exhaustive list. I just looked through gads of publications, and I got sort of overwhelmed. And I said, let me pick some that I think are interesting. So one first approach is, are we the only technological species that ever existed? So trying to rethink the equation. So could we really be alone? There's a lot of pessimism out there as far as, the likelihood of life in the universe. So these authors are like, well, maybe we can put a limit on how pessimistic you can be. So I know it's kind of a funny thought. That's what they did. Okay. And you'll see the numbers. And then the other one's a likely number of communicating extraterrestrial civilization in our galaxy. And you can state that another way. How likely is it that we will hear a signal from them? And I'll show you what I mean in a minute. So approach one, are we the only technological species ever existed? I put QR codes in here. Anybody wants to look at the articles? Right there. Okay. Welcome to them. So here we are rethinking the approach. Are the only technology ever existed? So one thing this approach does, it takes out that L factor, the life of a civilization. Okay. So what they start doing is they start clumping these things together. So N here is a number of technologically advanced civilizations in the galaxy on the left. And then you have these two factors, the star formation rate and the fraction of star planets and the number of planets. All these together come down to N sub AST, number of habitable planets in a given volume of the universe. Okay. And then over here, these factors here are really the likelihood of technological species arriving on one of the planets. Fraction of pseudoplanets with life actually appears, that could be intelligent life, and then that developed technology that could communicate. So in some ways, the way of saying this is really, I call it cosmic archaeology. We're looking at in the universe, history of the universe, are we alone? So we're looking back through the history of the universe. This is astrophysical aspects. We actually know those parameters pretty well. They didn't 60 years ago, but we do know them today. And biological evolution society, this is the great unknown. It's still a great unknown today. So if we look at N sub AST, number of habitable planets given volume, as they say, they're all well known. But these are done for radial velocity, microlensing, number of techniques. So the fraction with planets, pretty much one, okay, in that realm. The fraction with suitable life, about 20% potentially. And, a lot of these numbers are a little bit loosey, but somewhere around 20%. Star formation rate, that's an observable thing and is considered to be well known. So F sub ET, the likelihood of a technology on another planet, extremely uncertain today. Why? We only have one example for life, us, this planet. That's it. So we don't have anything else to judge it on. So the approach the authors took was saying, well, this value f sub bt, why don't we solve for it in the equation and figure out how pessimistic it could be. So here we go. Assume A, the number of technological species is about 1, us, okay? You run the universe 100 times, you get 1 technological species. Calculate the value of likelihood of f sub bt. So the equation's very simple. We basically A divided by n sub ast, 0.01 divided by, here's the number of n sub ast. So you come up with a value of 2.5 times 10 to the minus 24. So it would have to be extremely, extremely pessimistic to say in the history of the universe, life never formed, okay? It's a lower bound. Does that mean it happened? No, okay? And I'll give you some pessimism in a little bit, okay? So this sounds really, really exciting, okay? There's life out there. For the Milky Way, we're a smaller volume of space. So the likelihood is a little bit higher that you'd have to, that we may never have had life, okay? Not as big of a space as the universe as a whole. So the bottom line for this one is f sub bt would have to be very, very small for this to be the only technological species in the galaxy. Does it prove anything? No, but it just gives you a perspective on how pessimistic you'd have to be to say that it never happened in the history of the universe. So let's look at the other one. Number of communicating extraterrestrial species. This one is a very technological article. I'm going to give you just the highlights of it, okay? So Drake's asked the question, how much intelligent life is there in the universe? This approach, why life has not been found in the galaxy. So it's a sort of twisting it around a little bit and doing it. So this is from the Astrophysical Journal 2 or 4 years ago. So the approach here is calculate the bounds of communicating extraterrestrial SETI civilizations. And these authors called it SETI, okay, in our galaxy. They based this on Copernican principle. We all remember Copernicus basically said Earth is not unique. The universe doesn't revolve around us. We revolve around the sun. All kind of problems with the Catholic Church, all the rest of that stuff that happened. But the principle still holds. What these authors said, there's an astrobiological Copernican principle. We exist. So inherently they say we are not unique. So there must be other civilizations that if you give the same parameters that formed us, then why not have other civilizations? So they called that an Earth-like planet. They, astronomers aren't very original, SP, suitable planet. In a habitable zone of a suitable star, just a suitable amount of time for life to form. So Earth is unique. So this helps with the Drake equation, making some of those parameters go to 1. Suitable time, they assumed 5 billion years. That's how long it took us to come about. Idea of universal convergent evolution as well is being applied here. So the benefit avoids the terms FL and FC in the Drake equation, so which are currently not known. So the SETI equation is they developed it, these authors. The number of intelligent species communicating at the current time is equal to the total number of stars in the galaxy times the fraction of stars older than 5 billion years, times the number in the habitable zone, a number with sufficient metallicity, and the interesting parameter, again, the lifetime of the civilization comes in here over tau prime. Tau prime is the average age of stars in the galaxy over 5 billion years. Think of it as this parameter is how long a civilization lived over how much time they had to form. Essentially, it's a probability of detecting that civilization while it has a lifetime. Does that make sense to people? So we got to start doing some calculations. Calculate the fraction of stars in the galaxy older than 5 billion years. Do this, we need a star formation history of the galaxy and initial mass function. So essentially, how many stars with which sizes were in our galaxy. Data exists allow us to do all that. This is a plot of it. So basically, look back time to the beginning of our galaxy. Rapid star formation, and then it's been a slow tail off with time since then. So what you can do with this is, I think it's on the next here, basically curve fit it, that's the green line. Just do a finite element method, you can integrate right underneath it. So then once you do that, you can come up with these curves. So basically, it's a 2-axis. You got mass formed here on the left, the number of stars on the right. So total mass formed, total mass surviving. So you had a lot of big stars, not a lot, you have big stars formed, those blew up, okay, giving us the metallicity. But the total number of stars almost hasn't changed because most of them are red dwarfs, okay? And what you see here, we're looking back 5 billion years. And so you can see most stars in our galaxy are quite a bit older than 5 billion years. And this actually is another plot to show that distribution, cumulative distribution. So with age, how is it? So we're at 5 billion years. Mean age is 9.8 billion years for stars in our galaxy, with a median of about 10.4. So then next is calculate F sub L. Star formation rate history, stellar mass distribution, the distribution of stars surviving in the galaxy today. They went through a lot of math, comes down to 0.963. Okay, just to give you a number, okay? Shazam. So fraction of stars with metallicity. So this is a key one. This is using Kepler data. A number of astronomers did this work. So spectral type, remember your oh, be a fine girl, boy, kiss me, right? So, so these are F, G, and K stars, about 5%. Remember our sun's a G. So most stars are not in this category. M, the red dwarfs, 14%. So total is around 19. So they did include red dwarfs in their analysis. So fraction with sufficient metallicity for an advanced civilization. Remember I said before, radially and axially it varies. So then they did a bunch of calculations with the volumes of the galaxy in those sort of parameter spaces. Okay. And they made an assumption on metallicity. Basically using data, the estimate is to form planets, you'd have to have a star with metallicity somewhere around a 10th that of the sun. Okay. Then they did a range. They said, let's do a range from 0.1 up to 1. So pretty much most of their analysis was done that way. So 0.1, 5, and 1. And if you say same metallicity of the sun, about half of the stars would fit that. If you loosen that parameter down to 0.1, a lot of stars would fit. Okay. So the average age of stars in our galaxy, minus 5 million years, is tau prime. We know the mean age is 9.8, so tau prime is 4.8. Okay. L is taken as a variable. Basically, having Earth, the assumption was we've been doing communications for about a century, give or take. So they put 100 years. So 3 scenarios were given, 1, 2, and 3. 1 is greater than 5 billion years for the age of the star system, 4 to 6, or pretty close to around the age of our system. Tau prime then changes. So you end up with a number of civilizations, and I only show here for metallicity of the sun, V equal 1. 4.8 times L down to 3.36 times L. So if you say the minimum number of civilizations would be L is 100 years, that's us. Okay, so then you can actually say, okay, we can calculate then what that number would be. Now you could extend this L, of course, if you have advanced civilization, we're hoping to be that someday, that we can actually be on multiple star systems. So then your lifespan of your civilization could be much longer. So under scenario 1, that will calculate, given 100 years, the 475 civilizations minimally in our galaxy. Down to about 36. Okay, sounds pretty promising. But look at the maximum distance to the nearest neighbor. 4,600 light years down to 17,000 light years. Okay, this is the physical challenge of trying to get signals or communicating with other civilizations. So the minimum search time, using the speed of light as the calculation here, 1,300 years to 3,000 years. So the fact that we have been looking for 50 to 60 years and haven't heard anything, and it takes 5 billion years even for us, maybe we're being a little bit too, impatient with trying to find civilizations. Conclusion, potentially dozens of hundreds of civilizations are out there. And detecting a signal, though, is going to take a really long time. So time for some pessimism. But that wasn't pessimistic enough, okay? I don't want to be accused of being too overly optimistic. Okay. So are we alone? This is a guy, David Kepling at Columbia. Talk about a negative guy. Do you know David? No. You got to look at his YouTube things. Man, this guy's something. Okay, so he said, look, the common arguments for optimism that, you listen to Tyson, oh, Neil deGrasse, oh, there's going to be tons of things out there. Now, big number, billions and billions of stars, right? The Copernican principle, we're not unique. Life started quickly on Earth, and it did. Extremophiles exist on Earth that can handle almost machine gun fire, right? So why do we think it's so unlikely? Well, he says, big numbers. Yeah, Milky Way is big, but the number of civilizations, equal number of stars times a fraction of that have planets containing life. And he says, okay, 10 to 11 times fraction. But he says, we simply have no clue what F sub L is. And so he's saying it could be vanishingly small to zero besides ourselves. We have no scientific data. And again, the old adage that, belief without data is belief without data is faith. Belief with data is science. Okay. And so, believing that there's life out there with these sort of numbers and what we don't know is really faith. Now, some people have that faith. Okay, fine. The other Copernican principle is we're not special. We only have an N of 1. Impossible to actually predict from an N of 1 anything. So he's like, what are we dreaming about that you're going to take that and say, oh yeah, well, that means there's all kind of civilizations out there. Life started early. It did start early. About 4.5 billion years ago, the Earth formed. Around 3.5 billion, you definitely already had life, probably even sooner than that. But it was simple unicellular life for most of that history. Okay, we came along at the very end. Intelligent communicating life required 4.5 billion years to come about. Earth's going to be uninhabitable in another billion years. He's saying, boy, we came on late. Okay, so, if we had come any later, we wouldn't have made it at all. So it takes a long time to produce intelligent species from abiogenesis. Extremophiles, cute little guy here. Okay, so, that's a tardigrade. If you haven't seen those before, they are tanks of little things. They can handle just about anything, radiation, vacuum, lots of stuff. The thing is, they do exist, but they were actually nurtured into existence by a planet that actually had, the right temperatures and allowed different species to come, so they could actually evolve over billions of years to be these tanks. So his argument is, on another world that doesn't have those nice, comfy growth conditions, you wouldn't be able to develop a creature like that. So his conclusion is life beyond the Earth could be very unlikely. I think he said very, very unlikely. Overall conclusions, then, for this aspect of my talk, which is a quick summary of what I was going to cover last time. No evidence exists for extraterrestrial life today. UFOs be damned, okay? And we could have a whole discussion on the craziness with that. And we could be alone. But it's possible humans are not the only technological species that have ever existed in the universe, that one talk. Another is modern knowledge has to update the equations, but it could take a long time, more than 1,000 years for a signal to actually reach us or for our signals to reach them. So what do you think? Anyone have any thoughts before I move on to talk 2? Dave, you always have thoughts, come on. Who thinks there's life in the universe? For sure. Bruce does. Oh,
Including us, or?
no, I'm not.
Well, I'm not so sure about this.
Some people aren't, right?
Now, my thoughts, and this is probably the subject of a whole nother talk. This focuses just on technological civilization.
Yeah, I'm not talking about microbial or
and
even the dinosaurs. If the dinosaurs had survived, we'd have life on this planet, but no technological communicating life. We need another water. Let me just do one water. So that is a challenge.
I mean, so I think I got this right. About 4 years ago, Sarah Cedar at MIT, we had her here a couple years ago. She published a couple of papers where she redid the Great One.
Yep.
But it was all based on estimating with some of the same parameters, the number of potentially habitable planets. And it was based on likely biosignatures, looking for any kind of life, not advanced technological.
Right.
And the numbers vary all over the place, but then you come up with numbers that almost are in the realm of possibility, when you're considering the entire galaxy, the number of planets and moons that are in habitable zones, and suddenly places that these equations can't calculate, like icy moons that have subsurface oceans.
Right.
You know, suddenly now the possibility becomes not like almost zero. It becomes almost like within the realm of possibility, even if you're a pessimist. But where if you use these approaches, you know, you're really drawn to a very pessimistic, because you're looking for an advanced technological.
Right. It's a very different thing than what she's.
That then basically for 99.99% of humanity, nobody would have detected this,
Correct.
even though we were pretty advanced civilization. Right?
Exactly.
So it just seems like the focus should be a little different. You know what I mean? Just
Right.
give it a benefit of the doubt.
I'll mention in the next talk here a little bit about biosignatures and that work. So I'm familiar with what she's done. Yes, sir.
Yeah, one of the things you were kind of bouncing back and forth between galaxies and the universe.
Yes.
And if our galaxy, even if any was one in our galaxy, we're the only one in the entire galaxy, well, look at how many galaxies there are in the universe. So if you have one advanced civilization in each galaxy, you got bazillions of them.
Right.
So we may not be able to communicate, they're so far away, but it doesn't rule out the possibilities that there's life in other galaxies. So
Right. Yeah, I mean, I like to think of myself as an optimist generally in life. I think there's a high likelihood that something's out there, but I don't want to say there's definitely life out there. I just don't have the scientific data to be able to say that. So I always have people when I'm giving talks, like, is there life in the universe? I have to go into, well, you know, there's no data to say so. And as a scientist, I can't really say I believe in that because I can't.
And I agree with you, but one of the interesting things is that in putting the limits on the pessimism, even in the modifications that we're dealing with in the data that you just presented.
Right.
There's some wrinkles there that the authors probably glossed over.
They did.
For instance, the red dwarfs, they are around a long time. And even with the problems that they have of planets being close to them, they're up there around for a long time. And if everybody remembers Jurassic Park, life does find a way. So
Dear to my heart, I love that.
So, but the thing is that, you know, given time and pressure, things do happen. The other thing is the boundaries of where we're looking at your model of the Milky Way galaxy. We're looking at the outer parts and saying, well, maybe not as much metallicity. But those of us that have been playing with astrophotography and like to watch the galaxies dance, we like to watch the little galaxies getting eaten by the big galaxies. And we know doggone well that some of the older stars in the little galaxies that are getting eaten can wind up on the outside or the further reaches of the big galaxy that's eating them, and could actually maybe expand those parameters, but maybe not make it so.
Yeah, I mean, there are a lot of assumptions in everything I presented, and a lot of things you can pick holes at their analysis. So I'm not saying they're definitive by any means. And Bruce, your argument is a good one. I don't really have anything to say against it. Yes.
Can I just add one little thing? I just think, like, even though, right, we are all based in science but I think it's okay to have faith,
I agree.
right? Because I think faith keeps us optimistic, it keeps us curious, and we won't know.
We have to keep looking.
Right.
Right.
And I just think, like, it's okay not to know, but it doesn't mean that we just don't know that.
Correct. Yeah, I don't think there's any reason we should stop looking. Pete, you have something to say?
I was going to say, you know, this Earth is a good example that how long it existed before intelligent life came along. The example is, it kind of shows that all those billions of years you have, you know, dinosaurs and everything else, that intelligent life in our form is not prerequisite for life on other planets.
I guess the question is,
Planets could exist perfectly fine without life. I mean, without intelligent life.
correct. It's true.
You could have, billions of planets out there, it's got dinosaurs all over the planet.
Well, again, if the dinosaurs hadn't died here, I don't think mammals would be where we are today. So this world could be very different. That's one of the other things I didn't even talk about. He ran the same guy, David Kepling, ran a Bayesian analysis saying, if we reran the Earth again, how likely is it that man comes about? And it wasn't likely, because of all the odds of things that had to happen to make us what we are today.
Like that asteroid.
Like that asteroid, like the formation of the moon. It goes on and on.
Another thing is communication. I mean, in all the time that man's existed, he has yet to learn to have a conversation with God.
All they say is, hey, hey, hey.
You're right, we have it.
We can communicate amongst ourselves, but not beyond that.
It's true.
And then how does that play into other civilizations trying to communicate with us?
True.
Maybe, for them talking to us, it'd be like them trying to talk to a dog.
A fun exercise. Have you ever tried taking the signal we sent out from Arecibo to say about DNA and stuff? It's all in code. It's a fun thing to look at because would someone figure that out? It's like you have to know an image and raster. To your point, we make a lot of assumptions when we're reaching out, and it's our technology and our biology that we use to do that, which isn't necessarily what would be elsewhere in the universe whatsoever. Yeah.
Anything possible?
So, yes, sir.
The Drake equation is really nice for calculating the number of civilizations that might be communicating with us. And implicit in the assumption of communications is human communications, like the electromagnetic waves, whatever.
Right.
So there is there's that, and kind of a next one was a question. If perhaps we can see that human species is going to propagate into the solar system and maybe into other star systems. That didn't really seem to be taken into account, the propagation of life. So not just using the physics that we understand today, what would that look like, given enough time?
Right. You're basically saying the same thing Fermi said, which is basically if you have enough time and advanced technology, and his argument went roughly like, well, we can't do it today, but in a few hundred years, we'll have spacecraft that could maybe do 1% or a fraction of percent of the speed of light. And so if you're trying to get to the nearest star, okay, and you basically have a craft going with a population to go there, they find a planet there. We now know exoplanets already. So think in a few centuries what we might have, and then populate that planet, give it a few hundred years. You can start doing the math, do a few hundred years to develop the civilization, industrialization, start building new rockets, and then go to the next star and the next star. You keep repeating that. And that was basically his analysis. So it was like, basically within 10 million to 50 million years, you can populate the whole galaxy. And you're right, that isn't included in any of these analyses. Not. Okay. Okay. So let's go here. Did that already? So next talk. So that was, think about the probability. The next talk is about, so how are we actually searching for life? Okay. And what techniques are we using? And what are we going to be doing in the future? So to start off with, one of the things you have to ask is the question, what is life? What are the ingredients for life? Because I'm out there looking for it. I better know what those ingredients are. What makes a place habitable? And we've talked about that with the first talk. What places on Earth are maybe good models that we could use looking for places of where life might form? What conditions can life tolerate? Gets back to that tardigrade topic. What potentially habitable places in our solar system? And then how do we search the whole solar system and beyond? One of the key things is astrobiology. It's the only scientific field I know of that doesn't have an object or subject yet. Okay, but it's a key one because they're asking the questions. How does life begin and evolve? We know some of that happened, how it happened here, but not everything. But how would it happen in different conditions? How does life exist? Does life exist elsewhere in the universe? What we just talked about. And what's the future of life on Earth and beyond? If you remember my talk about Venus, from a year and a half or so ago. Venus is a crazy planet today. They call it our sister planet. And but it's molten lead on the surface. Atmosphere would crush us. But was it always that way? The answer is no. Talk about belatedly habitable. That planet was probably habitable in the first billion years of the solar system. So, but what's going to happen to the Earth? We already talked that, in a billion years, this planet won't be habitable. So think about that. Then common characteristics of life on Earth, common biochemistry. You need a way of encoding information that can be passed down generation to generation. Orange structures, reproduction, growth and development, reaching maturity, energy utilization, response to environment, actively senses and responds to external stimuli. Homeostasis, keep your body warm, maintain your body. Evolutionary adaptation, handling the conditions around you. This is from this primer, astrobiology primer, from NASA. If you want to read it, it's about this thing. I just skimmed it, so I'm not trying to say I'm an expert on this, but essentially this is astrobiology 101. So the working definition of life that NASA has been using is a self-sustaining chemical system capable of Darwinian evolution. Okay, so responding to the environment and the stimuli. Another one that they say is really one that predates actually Darwin is the Lamarckian evolution, which says that you could actually make adaptations during the lifetime of an individual. The example everyone uses is giraffes. Giraffes. And that giraffes basically kept reaching higher and higher to get to the food and ultimately modified themselves. And we're able to pass that down. Common solvent for life on Earth is water. We need water to help nutrients flow through our system, to get things out of our system, to control our temperature. It's part of the energy cycle. So it's key as we understand life. Alternatives have been proposed on other planets and bodies, from ammonia, sulfuric acid, methane, ethane. Nothing's been proven one way or the other if that's possible, but people are thinking broadly. Prerequisite life, readily available energy. On Earth, it's solely based, we receive from our host star, the sun. We receive about 1,400 watts per square meter on the surface, depending on season and latitude. Photosynthesis is really the core for things, and for a long time, that was assumed to be the source of all energy for life on Earth. Plants, phytoplankton, seaweed, algae, the basic forms of life that the other life feeds on to produce who we are today. But is it the only source for life? And the answer is no. So back in 1977, the continents have been mapped, the poles have been reached and explored. Mankind had already at that time walked on the moon. We thought we understood the ecosystems I was just describing, but then a research vessel was off the Galapagos Rift. There was a temperature anomaly and they wanted to explore it. No light penetrates beyond the euphotic zone, so about 200 meters down. So no photosynthesis is occurring down there. At a depth of about 2,000 meters, they found what we call today sea chimneys. They didn't call it that, or hydrothermal vents. They had but it bounded with life. And they were actually getting life right from the energy right from the geothermal vent. So they're actually using fluids and gases for energy. And then those were consumed by larger and then larger organisms. So just saying that you have to have photosynthesis is not really true. You don't need that as a mechanism for it. And this is actually one of those. You get an idea of what it looks like. You've probably seen pictures of this on TV. And this is the life that's around it. It abounds. So where do we look for life beyond the Earth? Obviously, in our solar system, planets, we want to be within the Goldilocks zone for liquid water, and moons beyond the typical Goldilocks zones that have enough warming of some sort to have liquid water. Okay, so the giant planets like Jupiter and Saturn are really where you're thinking about you would have that conditions. So to find life, just a quick summary of what I was just all talking about. Temperate zone around the star host body, present of water, source of energy, whatever that is, necessary components for life, time to have sufficient time to develop life, and maybe others. We don't know yet. This is sort of the thinking that astrobiologists are looking at. So let's look at some missions and programs looking for life or signs thereof. Mars, obviously. No evidence for life at this point. Planet likely have been very different in the past. Just like we were talking about Venus, Mars was also probably had liquid water There's plenty of data that suggests that. We found carbonate rocks on Mars, so it's very likely they had it, that they are too light to have held it. Objective for Mars rovers on Mars, geology, we have had a slew of them, Curiosity, Spirit, Opportunity, Sojourner, and others. Search for life, it's really Perseverance that's there now that's looking for life. This is beautiful Mars. Today, it's a cold desert. Okay, this is from Curiosity. And remember, our biological timeline, it took us a long time to get to us. So the Southern Lights here, it's thought that Mars changed climate somewhere around 1 billion to 1.5 billion years after its formation. So first familiar fossils that we have here on Earth, like, you know, that you would see like fish or whatever, really you have to be down here less than 1 billion years ago. So when you think about time, Mars didn't have enough time to develop very sophisticated life. We had life quickly, but it was very simple life. Chances are Mars, if it was able to do it, had simple life as well. So if we saw this on the left, game over. You know, we'd be thrilled. We'd say, prove it. But this required billions of years to form that Mars didn't have with the conditions. This is more likely what we're looking for. These are called stromatolites. And basically they're microbial mats that form. They form here on Earth. And they were basically, this one here is about 3.6 billion years ago. So around the time that Mars would have been changing. These are them today in Australia. Okay, so they exist. And so that's what we're thinking we're looking for when we look for the samples on Mars. Mars rover, the Curiosity rover here, it's been on Mars since 2012 at the Gale crater. Really great chemistry. Chemical and mineral evidence of the past, habitable environments on Mars. Okay, continues to explore rock record in this time. And, you know, basically it could have had home to microbial life based on what data it has. Doesn't say it was, could have been. Perseverance and the little air helicopter that's no more. Okay, Ingenuity. Been on Mars since 2021. This one's a little more complicated. Expected findings, they went to a lake bed, you may remember. And the thought was, you know, it had been flooded and it looked like it had been flooded. And they expected layers of clay and silt. This was basically from visual information from space. Findings, though, that were initially surprising, it was volcanic. Okay, it was not the sedimentary. And so they're basically using spectroscopy. It was like, oh, but this was actually a much more complicated story. So basically the story they've assembled today, based on all the samples they've got, the Jezero crater, shallow impact crater, about 45 kilometers wide, just north of the equator, formed around 3.5 to 4 billion years ago. Igneous rock seems to have formed, lava came in initially, and then there were several lava events flowed into the crater. Sulfates finds required water there, so there was definitely some water. Sedimentary rocks then came after that, and they were doing a lot of searching to find those rocks. They finally found the sedimentary rocks. Okay, and the carbonates, sulfate, and a variety of salts. So there was water there at one time. More work needs than what we already have to ultimately get these samples back to Earth so we can analyze them. One problem is getting those samples back. So the notional 3-mission sample return is, we're here today. We got the little bugger on there, he's doing his job. Now we need a return system to get there. Mars Ascent Vehicle launches, and then it docks with a orbiting station that then returns it back to Earth. The evil face of budgets comes in. Challenge, it was just recently estimated this would cost over $11 billion, more than the James Webb Space Telescope, to bring it back to Earth. Science, electorate and such really want these samples because it's the only way we're going to know if they get back here. Little Perseverance is chugging out those little tubes, putting them onto the surface, but somebody's got to pick them up. Right now, JPL just downsized. You probably heard that, because basically, if you saw the budget that came out yesterday, I was looking at that budget. They basically slashed this Mars return program at this point. A little bit left, a few hundred million from like $1 billion. They were actually just last year. So you can see why they fired the people. It was a sad day at JPL. I was talking to one of the people on the day that it actually happened. They're like, we're going crazy here. So this is in limbo. Not clear when and if it'll ever happen. So with that cheery note, let's go on to beyond Mars and solar system. So gas giants, as I was saying, anywhere else to look, of course, the moons. You know, life inhabits the deep, warm ice and ocean environments here. And so let's look at those around the system. These are the moons being considered: Enceladus, Titan on Saturn, and the Europa, Ganymede, and Callisto. Surface Jupiter is cold. You think, well, how is it possible? It's about -110 on Jupiter. Heating on the moon's eye, surface temperature is about -143, so it's cold. But it has volcanoes all over its surface. The lava coming out is estimated to be 1,700 degrees. That's all due to tidal heating. Io is so close into Jupiter that not only is it Jupiter's itself, but also the other moons going around are perturbing it. So it keeps pushing it in and pulling it out, pushing it in and pulling it out. That is causing it to heat up and essentially causing tides in rock of something like 100 meters. It's an incredible amount of just basically liquefying this moon. One beautiful thing about it is it's spewing out all of these elements into space, which are going on to the other moons. So these are things that would be like phosphorus, etc., that would be elements for life. Okay. So basically that's that part. So you think we have a lot of water? Au contraire. Earth, if you took all the water on Earth, this would be the ball that would be formed. On Earth as a whole, water is relatively rare. It just happens we live on the surface and 70% of the surface is covered by water. Okay, but it's only a little thin skiff of water compared to the thousands of miles of diameter of this planet. And if you look at Europa or you go out here to Ganymede, look at the size of the water that's out there. Dwarfs us. These are really water worlds. We just have to get down to it. Okay. So detecting life in the solar system with telescopes, obviously Hubble, Webb, and others. There's in the future coming out. Biosignature using gases by spectroscopy. And James Webb detected CO2 in the atmosphere of one super planet. Oh, actually, that's a star, 700 light years away. I thought it was a star. Is that a star, Roger? Do you remember that? B, it's B. That's a planet. Sorry, the stars last 39. Sorry, my mistake. Exoplanet atmospheres. This is a search for biosignatures. I was going to talk about. It's a good way to assess the habitability and possible whether it's inhabited. And basically, a lot of the work done so far has been on hot Jupiters. Our technology to detect exoplanets not that sophisticated. They have to be relatively big planets. There's whole plots. I won't go into it today of the size of planets we've been detecting. Really have not detected hardly anything that's close to a terrestrial planet this size. Most are at least super Earths, or most really are these hot Jupiters, and they are several times the size of Jupiter. Earth-based telescopes and space-based are all working on this. Transit spectroscopy has been used, gravitational microlensing, where you're using the fact that a very massive object could allow you to see very distant objects very well. Coronagraph, in some cases, to actually allow you to see the planets. This is actually the technique. So if we're lucky enough that the path or the orbit of the exoplanet around its host star passes between us and the star, then the atmosphere actually has some of the light from the star coming through. So if you do spectroscopy before the planet's there and when the planet's there, subtract one from the other, you end up with what's left in the atmosphere. Biosignature criteria. The big questions is reliability. Biotic versus abiotic sources. Okay, you have to say, okay, just because I see oxygen there, is it really from life or is it not? Survivability. Can planetary sinks be saturated? An example is really Venus. Venus doesn't have plate tectonics, so it didn't have any way to sink the CO2. So the CO2 all ended up in the atmosphere. We have as much carbon on our planet as Venus has, and yet we only have 0.04 something percent CO2 in our atmosphere. Where is all our CO2? It's in the rocks, and that's because of plate tectonics. So it basically churns over the eons, basically absorbing all that. So those are sinks. Detectability, just equipment-wise, can we detect it? And is there overlap with other species that makes it hard to basically deconvolute what you're trying to look at. Oxygen as a biosignature. It's a great signal on modern Earth, but it wasn't always that way. As I said before, Earth billions of years ago had life with no oxygen. Yet it was life. So, you know, you have to say, well, just because you're looking for oxygen doesn't mean it's really there, or it could be a false positive, because phytolysis, if it doesn't have a good magnetic field around it, could hydrolyze water or CO2. Okay. And if you were to say, okay, wonder if somebody, little green men, another solar system, or planetary system, were looking at our solar system, what would they see? This is Venus. They would see Venus here. So you'd see these chemical compositions here. You'd see some water, not much. If you looked at Earth, you would actually see here, you would definitely see a lot more water, and you would see oxygen. But you would also, over here under Mars, you would also see some of the things. There's still water in the atmosphere there as well. So you would have a signal here that says, yeah, Earth probably has got potential for life, but nothing that would jump out at you and say definitively that it has to be life. This is what makes it complicated. So there you go, for the oxygen and the water on Earth. So astrobiology missions current, we've got a whole slew of them here from Hubble down to James Webb. Some of these are, you know, things that are actually going out there. Other ones are telescopes like Webb, Perseverance, etc. as rovers. Future, we're looking at the Europa Clipper. It's supposed to launch late this year. As far as I can tell, their budget hasn't been slashed. So they should go. That would arrive around 2030. And so this is from the European Space Agency. So that will be an interesting one to see what's going on in Europa. It's really an orbital mission. Dragonfly mission is really cool. I'll show a thing on this one. This is going to launch, they still say mid-2027, arrive around 2034. And of course, the Nancy Grace Roman Telescope is going to have a really broad view of the sky with incredible spectroscopy and be able to do coronagraphs where they can block out the host star's brightness so they can actually see the planets around it and get spectra on them at least 10 times better than any equipment that's come before. Okay, so very exciting possibilities with that telescope. The Dragonfly mission is going to actually take what we did with a little ingenuity and take it to a whole new level. You know, on Titan, it has an atmosphere around that of Earth. So you can actually have a helicopter go around pretty well. So they're actually going to have this good sized rover that's actually a helicopter going around the thing, and they can basically take samples. Here's the URL for it. And basically it could be really good. Their plan is to land during a calm weather period, somewhere around the Shangri-La to dune fields that we know of on there. And basically it's hoping it'll fly somewhere 100, maybe longer. NASA always underestimates the life of these things. You know, we still got these things going 20 years later. Nancy Grace, 2 instruments, going to have a wide field and a coronagraph. Basically, exoplanets is one of the key things. It's also going to do dark energy. It has multiple objectives, but for what we're talking about today, it's really about the exoplanets. And this one will be a game changer if it works the way they say it is. With that, that was both of my talks. Hope it wasn't too much. Thank you. Comments, thoughts?
Now you said that the sort of thing that we both pessimistic to the optimistic. What do you think?
I mean, I think it's, you know, there's good likelihood that we'll see potential microbial life on some of these moons. I think that's be very interesting. One thing I had to cut was the whole thing about, well, how are you going to do that? And NASA is developing these really fascinating worms that actually will dig down through the ice and go through kilometers of ice to get down there, to get to the Irish liquid ocean. So it's going to be pretty fascinating to see how that goes. They're actually in Antarctica and up in Greenland trying these out at this time. So I think it's you know, microbial life, it's hard to imagine that doesn't exist. Again, I'm being a faith guy here, but you know, it's I think it's likely that that's going to be found. Us, I don't think there's anyone down there, you know, driving submarines around underneath there. That's me. How about you?
The numbers are so staggering. You know, as somebody who's spent quite a bit of time just photographing just the easy galaxies that they are. And I think about the numbers involved. I think it's probably damn likely that there's probably intelligent life out there. Whether or not it has anything to do with the price of eggs is a good question. It's so far away. But that I can even think about it, and even look at that, and even try to see just better senses. To me, is what it's interesting. So yeah, I'm an optimist.
Yeah. I mean, I can't imagine there's not something out there looking up at us from another galaxy or another part of our galaxy, wondering, is there something out there? You know? So I'm also an optimist, but I won't say definitively they're out there. So.
Life so complex on this earth, it's hard to believe that it's not existing elsewhere. You got life on top of life and everything else here on earth, it's just a complex.
It's like once it gets going,
I
it's,
believe it doesn't exist out there.
yeah,
As far as advanced life goes, well, like I said, you know, that could be a different thing.
right,
It's not a planet for life on a planet.
yeah.
Earth did find it for a long time before man came along.
And you know, I mean, how long will we exist? I mean, hopefully we'll be able to exist for thousands more years, maybe tens of thousands. But we want to make sure we are the people, because if we're the only species, the responsibility of mankind is huge. It's our responsibility to populate the galaxy. And if we screw it up, that could be it. So let's not screw it up.
What are your thoughts about the possibility that life could be transferred between different solar system objects?
You know, you like whatever the emojis you, whatever that thing that came through. I think it's possible. I mean, that's one of the things they want to do all this work on asteroids. It's like now is a whole other talk, but on asteroids, it's like a golden age of asteroids. And so some of those are coming from other planetary bodies, or sorry, other solar systems or star systems, and they could be definitely carrying some things. And certainly what we see, just the ones in our own solar system, definitely have the components for life in them. Just the ones that came back on the Osiris-Rex are showing it, and they haven't just started looking at those.
Right now, they got the lid on.
Yeah. But they did get 120 grams. Whether it's like, you know, before it was like half a gram, and that the Japanese brought back. So this is a huge amount, but we just started with it, but it did take forever. I'm like, just dry it off for God's sakes.
I'm kind of thinking more in terms of like a meteorite, where you have an impact on one planet that flings stuff into space, and that stuff then travels through space and potentially lands on another planet.
And I'm saying that's
Yeah.
but that would be then an asteroid from another planetary, you know, another star system coming here. So I think it's possible. Yeah, it's definitely possible. You know, we know that there's samples of Mars on our surface already. I mean, we've got those samples. But you know, they've had hell back through the Earth's atmosphere. But yeah, it definitely happened here. So did Mars have life first and give it to us? I don't know.
We're Martians, right?
Maybe we are. Maybe we're descended from Martians. Maybe microbial Martians. Maybe we started there. I don't know. Because there was a lot of bombardment in the early solar system, right? So that could very likely happen.
As long as we're not the golden creatures from the hitchhiker's back.
So, I have my towel with me. Don't panic. Don't panic.
All right, is there a plan B to get the Perseverance sample analyzed? And we can't retrieve them. I mean, is anybody looking at sending the lab there, for example?
There's discussions of looking at all the possibilities right now. They're not coming, they have, at least as far as I've read. If anyone else has heard, please. But as far as I've read, I was looking at that very question. They haven't come out with anything definitive yet. Because really it's the budgetary number. So they're trying to see how can they do this for a lot less than 11 billion.
Yeah.
And NASA right now is really focusing more on the automated probes going out and the space there and the moon. Moon's really the #1 priority. We're sending man to the moon. I know, but it's the PR aspect and it's what the White House wants. Okay, so of course then they want to go to Mars eventually, again with humans. But you know, as Roger and I have talked, you know, do you want to live in a lava tube on Mars? There's no shielding from radiation, no water, you know, on and on you go. I have a whole talk at Rogers Street, space wants to kill you. And it's funny when you look at all of it, it's really out there to kill you.
Where's that?
Well, you can kill yourself pretty easy, but they are a good way to go. I love it.
That's a nice dream to travel in space, you know,
It sounds great.
you know, man traveling in space just has more to it than just a machine.
There is something of panache to have that, and that's why we're pushing it wide. You know, of course, there's a lot of people who are making money off of the development of that stuff, so the congressmen want to have those in their districts. You know, I mean, we could be as negative on that, but still, I like the idea. I mean, I was thrilled about becoming an astronaut at one point in my life, crazy as that was, but, you know, why not? So I think it is important. It gives Matt a public face that's appealing. I'm just saying, it's all deep science. You're not gonna get much of the community out there to want to pay. So budget down 200 billion, something like that.
Also,
I'm always gravitated.
Geopolitics.
I'm always convinced anyway, if they ask me to go, I'd be there in a second.
Would you? Okay. They actually just said they're looking for a new astronaut crew, so, you know, you could. put your application in.
old for that.
You know, I looked to see if there's an age limit. And I'm like, should I? And there is no age limit.
There's no
because
age
they can't do that.
You
So
just have to certain degrees.
Yeah, you have to have the degrees and you have to be able to pass with this.
That is.
So they're gonna get you there. We want a 10-mile run in under 5 minutes.
20 miles a day on my bicycle.
I won't let you do it on the bike. So I hope you've enjoyed it.
Thank you.
Thank you. So with that, I think if you want to stay around, we're going to talk about outreach. If anybody's interested in outreach, if outreach is not your thing, have a good night.
And Bruce, if you wouldn't mind just giving us a quick recap for what's up next month?
Oh, sorry, I thought that was it. My fault.
So you're gonna get an announcement of this. So next month, because of the eclipse, we're not having a meeting the normal day. It's pushed back to the April 23rd, Tuesday, same time, same place. And Roger is going to give us a talk on essentially the sun and the sun. What a surprise. It's very appropriate. So that should be really good, but it'll be on April 23rd here. And in May, the last talk for the spring, we're having the speaker that we should have had in January. And her name is Erica Nespel. She's an astrophysicist from Goddard. And basically, it's going to touch on some of the things we just talked about. Essentially, some of the ethical and bioethical considerations of living in outer space. And like things we don't even think about, not just the physical, but legal issues and a whole bunch of other things. So she's written a really good book on this.
If you get a chance to read her book,
The
it'd
book
be
is
a
really
good
It's
primer.
called-
I don't remember either.
That memorable.
I barely remember my own name. I'll tell you what.
In outer space. Really, really good. So that's April and May.
And hopefully for our April meeting, some of us may have captured and documented an eclipse. Good luck to everybody who's gonna try. See you next month. Bye.
That's terrifying.
No, I'm interested in outreach.
And if anybody's staying around this area, you know, we're running a program of Hibernia on Eclipse Day if it doesn't thunderstorm or. So I'm gonna be there about 11:30, 12 o'clock.
You're okay with
And
something?
the program.
You don't have any questions about?
No,
something?
I'll be fine, yeah. I just pulled the plug.
Pretty nice time. They're expected
You get very
500
pessimistic
people,
if you want to. That's
but
the
if it
challenge.
rains, we'll probably
Yeah.
not get
Anyway.
that.
Like people, appreciate it, right?
Yeah.
Over at Exeter.
Apparently there was some problems. But they got that ironed out.
Okay.
So it's be back in there.
Yeah, who's new? You know, done all the subset perceptions in Europe. People remember that.
Yeah.
I think that's why this is nice. It pulls together.
Okay, great.
I'm gonna leave the,
What's that, Tom?
I'm gonna leave the.
Oh, that up, yeah.
You're very important.
I can stuff it out.
The halo, but. That's it.
Oh.
Jamaican Mountain Blue.
And so it's one of the, we were at the lookout.
You want me to start it, Don? or yes?
Yeah.
Yeah.
So guys, if we can get started on this piece, we don't want to hold you too long. So this is about outreach. Basically, Mike and Don and I have been chatting about, outreach programs we've had in the recent past. And, how do we make the outreach as enriching as possible for people coming to our events? And, the NSN network has a lot of great materials. And I started looking on the web to see what other clubs are doing and some of their stuff. And, I think there's opportunities for us to make it a richer experience. And I want to have this as a discussion, and that's just really what this is intended to be tonight. What do people think? What can we do? Are we happy with what we're doing now? Or can we do something else? So to enrich our outreach events, increase the number of members at the outreach is also a key. We're struggling with a small amount of people coming out. Even if you don't have a telescope, just coming out as an enthusiast and being able to talk to people there is valuable, okay? If you're good with binoculars, valuable, We can walk around, you can point out stars to people. You can talk about the lore, okay? So there's a lot of ways we can make it that even if you don't have a big mega telescope, it can still be very valuable to us. So goals here is really, I want to see if we agree on the need to look at maybe doing some other things, what materials we already have, identify that we need to acquire and discuss path forward. So this is from Mike, just showing you what we have coming up. This is just through May. So we've got quite a number of events that are coming up, both solar as well as nighttime. And this is a few more. It's a little dark here. Sorry. This is just through May 1st. So yeah, I'm sorry, Roger. It is a little dim there. It's not your eyes. Okay. I know you're old. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 events, okay, coming up. So a lot of events going, and that's just not even through halfway through the year. A few thoughts for future outings. And this just may be a way of staging an outing, okay? Pre-telescope time. So it's still light out. We haven't hit astronomical twilight. People have arrived. Then we have some materials available to engage and build anticipation. So rather than people just coming up to our telescopes later and going, what is that? And we say, well, it's, something. And they're going to say, huh? And so the more that people understand what they're looking at, and that you build the wonder, basically, that they're going to have, rather than just saying it's a nice point of light. Have activity or two that maybe can engage young attendees. I'm thinking back to a recent one with the Girl Scouts. They were a madhouse all over the field. We didn't engage the kids at all, pre-observing, okay? It'd be nice if we had maybe 1 or 2 things that could actually teach them. One I like the idea of is you can do the cratering on the moon. You basically just have a thing they can throw stuff out and actually see how the craters are created, especially if you're going to observe the moon that night. Okay, it would be really nice. And Roger, please think about, come in with the solar observing, because most of mine was thinking about nighttime. I'll be honest with you, okay?
Of course, most people night sky network,
Really?
It's taken them a long while to accept solar astronomy.
You guys.
Come on.
So just interject, please. Okay. So that would be pre-telescope time. I'm just thinking like maybe a table or something we have with some material on it. And then telescope time, have a plan for how the scopes will actually be used. Rather than right now, we all come out and it's like whatever each of us wants to put on our scope. Sometimes it's the same thing, especially if it's like not a great night. We're all showing Jupiter. Okay. So it's like, come on. And also we have to be versed on whatever object we're looking at. Shouldn't just be, okay, it's Jupiter. We should know something about it, be able to tell a story. So everyone's arrived, not dark enough yet. Start with a walk around of telescope mounts, discussing the various types. Dave, you're excellent at that. And, that's something you excel at. And any of us could do it, but I think this is something you excel at. Have a handout ready for how to select your first telescope. We always get questions from some people about that. Discuss light pollution and need to use a red light tonight. So it's not dark yet. Have some red cellophane and maybe rubber bands to put around people's lights, flashlights, or cell phones. And we could tie that into a citizen science project even on light pollution. You can use the app on your phone to actually measure the light pollution wherever you are. As it gets dark enough, start with a guided walk through the constellations and some stars with a bit of lore. Now I just put down some Orion, the Great Hunter. He's been chased by his nemesis, the Scorpius, and he's still chasing him through the sky today. Betelgeuse, a red supergiant, hundreds of light years away, etc. So big our solar system would reach out to Saturn. You know, these make it like really come alive for people. Let everyone know they don't need a telescope to enjoy astronomy. Naked eye is really good, okay, as well as binoculars. This is from the actually this one I think came from Night Sky Network has a version of this, and this one is actually from I think NASA actually one of their sites, but it's called a treasure hunt. I really like the idea of this. So you know somebody's looking at the moon, somebody's showing a planet, someone's showing some stars. They're with a planet, so pick one that actually has an exoplanet around it. Show it. Could be Betelgeuse, could be whatever. Red stars. Show one that's a red dwarf. Open clusters, galaxies. So we would assign each person at the thing, and you know, somebody can say, Pete says, well, I really like to show clusters. Okay, fine. You take you choose what cluster tonight you want to show. Dave gets some galaxy that he's really sexy on, you know? No such thing. Okay. All right. So these are some more Star Nursery, Planet. You can choose from these. You don't have to hit every topic, but we need more people at these events to have a hope of doing this. Okay. Well, I think you'd need at least 3 to 4 scopes to really do it justice. If you had 6 scopes, I think you're really cooking them. Okay. And we would have a handout. It's a 2-sided handout. People could get that before it gets super dark and they go around and say, oh. So, you know, Dawn's showing off some wonderful cluster. He shows it, you know. You're showing something else, say dead stars, planetary death. Okay. So this start to hand out the treasure hunt sheet, encourage everyone to mingle around the scopes. If a sea star or another smart telescope is available, Dawn has one, I have one, I think there's several other Dawns.
5 in the club.
5 in the club already. This will be really valuable to us. I think could be a game changer because we can set it up on the table and basically say, show me Andromeda. The nice thing about it is we tell people that's Andromeda and it's building up an image. And Dave knows this really well. It takes time to build up an image. So encourage people to come back and keep looking at it as the image gets more and more developed. And it's amazing what that little scope can do. So I would see putting like a lot of times we live in a suburban environment. The night sky isn't great for a lot of the dim fuzzies. So put it on a dim fuzzy. You choose your favorite that night and just have it start building an image. So people can just mill around that. And besides the other scopes around, you know, have a conversation with people about what do you see? Ask them questions. Rather than you telling them, see what they tell you they see. And then you can interject with some of your knowledge. These are some personal starter materials. I mean, treasure hunt, I just mentioned. This SNN has a star map. I mean, Dawn puts out the sky maps all the time. Moon map from SNN. The moon banner. I think, do we have a banner, Dawn? We don't have a moon banner. It'd be great to be able to talk about it. Be nice to have it like on the table, like in the front of a table. So if we're going to show the moon that night, be able to point to the terminator where it is and some of the features that you're going to see.
I have a beautiful, large, laminated and reversed.
That would be awesome.
Yeah, I have one of those, and they're easy to get.
Okay.
Yeah, they're not that expensive, but you need a table and you need some form of light that isn't going to blind everybody.
Well, that's exactly it. We'd have a table with a red light, I would say a dim red light so people can see it, as well as the other material that's there.
Except I can even read it.
Yeah, I mean, there's a little money that would have to be invested in this.
Yeah.
We did a nice table. We need some lights to put on there dim. And with the where is it now? It's on the Sea Star. It'd be nice to have something that's blocking people off from touching it. Okay. And you know, so what the one Dawn and I exchanged articles on this, and basically they were actually putting LED light ropes around it. That showed, you know, so people would actually funnel by. So they actually going to have a map of it. Let me just finish this. So activity to consider added. Just consider the creator activity for the young ones. Here's a link to it. Dark sky wheel. How good is the night sky tonight? So they start thinking about light pollution. Maybe at your house, you should start thinking about having some lights changed. Don't put your lights on outside all the time. There's probably lots of others. I've just put these out for ideas. Other materials considered, new astronomer quick start guide. This is a wonderful one from Cloudy Nights. Could be a handout. Bucket of cheap binoculars. Some clubs do this, have a whole bucket of cheap binoculars. You say, you know, somebody who's really good, like Dawn's with binoculars, says, come on guys, everybody grab a binocular and I'll take you over here and we'll show you what you can see with binoculars. And then most clubs, I was looking to see, Or they lose them binoculars, and they said, no, they get them all back. They don't have to be expensive ones. They were like $20, you know, something like that on Amazon. Demonstrate the star hop, you know, how you do it with binoculars, you know, and you can even repeat the, you know, we start the night with a sky talk, maybe halfway through, if people are coming late, do it again.
Get Kathy to do that.
Yeah. And then point out Abereo visually.
For that, Don. Don,
this
I
is
think, I think Roger and I with the laser pointers was always fun.
You're the best. Okay.
No, Roger was the best.
Roger was.
So this was just like, say something like Abereo, you show visually, they show through binoculars, and you show through a scope. So you progressively go up. And then maybe you pull people away and have them download an astronomy phone app so they can actually see what's going on. So you're not ruining anyone's night vision. You pull them off to the side and you just show them. Again, these are all just ideas, guys.
The martini asterism always caught the adults in the group.
Do we have to provide the drink with it?
No, but there's an olive.
So we already have these two things here. We have some solar glasses, and I have some telescopes, those time machines. So these are things. One pager Don won. As much as I don't want that, these are what he has already. So we already have quite a bit of material that would be nice for you know, a table at our events. This is one the site have with the C Star, where basically you'd have it right here, and people could either just mill around in front of it with some type of display device, or I like this idea. If you don't have a lot of people, you have them come in, funnel in. This way, the C Star is set up so basically they can see that as they're waiting to get to the telescope. Okay, coming off. Okay, it's a way of crowd control. You know, sometimes we get mobbed, and you know everybody's at that one scope. Okay. So if you had 6+ scopes, I think you can run that. What I'm saying, you could do the treasure hunt. You can have a pre-event activity for young kids. A lot of things open up. I think if we have enough members coming to that. 3 scopes, I think maybe assign each person 2 different objects they look at. And if it's 1 to 2 scope, I mean, you just try to avoid overlap as best you can and to handle them all. Horde, as I said here. The table with red light, back to that question, to your point, Dave, I need that. And, you know, that'd be helpful, I think, in all the scenarios, having something where there's some material there, club information, etc. Elephant observing field is, we just need people out there. I think that's the end. Yep.
Well, how about, just thinking from the president's point, should I start surveying members, including some of the folks that are perhaps in the Chester County group, who's got a telescope, who has binoculars, and sort of like maybe start tickling them before events, saying, okay, we've got this coming up, can you help? I have to say that, yeah, it can be frustrating when event after event gets flattered out. But I think that maybe if those of us at exec know who's there, who has equipment, and is actively on the phone or, you know, sending out the emails, you know, shortly before events, say a week before, maybe that's a way we can increase participation. I think you're right, Don. I think that there are just a few of us that are like real gearheads and that want to get out there. But they're not the most valuable people there, like at the helicopter museum. Our most valuable people, believe it or not, are inside at those tables handing stuff out.
Right.
And that somehow, I think, gets lost with the membership. We have to push for the people that don't have a skill.
Right. They just love astronomy.
Yeah, just, we need your help, you know, if for nothing else than just to hand out a CCAS brochure. That was so valuable.
Right.
It doesn't matter what that. I'm happy to give somebody a laser point that knows this guy and say, here, you work while I'm showing you, I'm trying to get people to guidance. Right. But I think that maybe, and I've noticed that this is also true in some of the other clubs, it's not just us. But other clubs are more gearhead oriented, for instance, CCAS March. Right. They just have a lot more people with gear that they want to get it out there.
Right.
We're not that. We're kind of diverse. I think yours is usually the largest scope.
It usually is.
And I prefer something a little smaller, something almost as big, maybe something like the West. But I have plenty of small telescopes. I can 10 people as long as inventory and a survey.
And encouraging people that, just your enthusiasm of being out there would be very helpful. So don't be frightened that you don't have, you can't do a sky talk, okay? So you can do something else. Just talk about whatever it is you're loving the sky.
I have to tell you, it is intimidating when you first do it. I mean, I would watch Roger do it and say, I can never. But, yeah, there's only one way to get to that point. That's
You really have to just do it.
You have to get out there and screw up a few times.
Nobody's judging you, so just go out there and do it. We'll all just love it, and if we chuckle, it's enjoyable.
Yeah.
Well, what do you think of the treasure hunt idea? Does anyone like it, or is it just like?
That's a great idea.
Don, I'm Meg, you know, correspondent.
Yes,
Yeah, so I would love if we could try it out.
we've talked about it for your event, right?
Yeah.
So that's what we're actually trying to do, the treasure hunt there. So see if we can get a few people with different objects. Still haven't decided on that, but we'll do that.
Okay, I guess we can break it.
Yes. So, Don, comments?
It might be worth some of us trying to attend the Chestnut Star Fest they have at, I think it's Hopewell State Park. Because that's their big thing of the year. That's when they do this stuff, but they only do it once a year.
Is that right?
Yes.
They have like a dozen scopes, it's all assigned, they have a path,
Yeah,
they have things.
you mean chestnuts?
Chestnut, sorry.
Yeah, they,
So maybe some of us attending that to get some idea. I think it's in August.
I
I
think
know
you're
it's a long
right.
way off, but it'd be worth attending to see how do they manage that? But to do that 7 times a year would be impossible. They do it once a year,
And they're exhausted.
yeah,
and they're exhausted after, right?
yeah, what you used to do is assign each person an option for what their type.
And we've done that at some of our star parties, it's not recent.
No, we used to do that back when we were at Hoops Park.
The Hood Park, we did that.
We tried to say, okay, who's got the big strokes, who's got the
Yeah,
big
yeah,
strokes, who's got the small strokes, and try it.
You don't want to think God on a period.
Yeah.
No.
The real key is to find someone to carry the torch.
Yeah, I mean, this takes, like we're doing now, is, ahead of the event, planning it, and saying, okay, who wants to cover what object? And your equipment and what's gonna be up that night. So choose what you think is the right one, and just agree that what we're gonna do. Because when you're on the field, it's really hard to do that, it's too late. And then we'll all go to our favorite objects, which might be the same as your object as your object.
So worse than that, in the summertime, and this is the part that really galls me, is that the people that are asking us to come and do an event, they want to do it while it's still light outside. Right? And it's like, I feel like I'm out there in my skivvies there, I got all this beautiful gear. It's just, the sky's too bright. And then by the time when we start to be able to see something, we're just getting to the point that some of the people with the bigger scopes, who start showing clusters, galaxies, that sort of thing.
They go,
They want to shut down the event, even if we are willing to stay there till 11 or midnight. Right? It's 10 o'clock time. Sorry.
But to put all this and all the scheduling and all the arrangement, all the phone calls we know onto the building chair, there's a lot to ask.
It is.
But I did it for 16 years, just being on schedule. Now to put the management of the start event on that with the team, that's asking a lot. But this is gonna take some time and effort. Who's gonna carry the team? Who's gonna keep all the documents? Who's gonna print it? Who's gonna get the lights?
Yeah.
A lot. I mean, it's all good stuff, but we need a torch bearer.
that's why I think we do, we need to start small. I don't think we plan on every event being.
Right, right. But pick a couple.
Pick a few.
Yeah.
I'm thinking maybe 3.
Yep.
I'm really excited 4, and see if we can pull that off. I think your idea of attending the Chesmont would be great.
I mean, like that event we had up at the Battle of the Clouds Park.
Right,
There are like 150 people there. That'd be a great place.
that would have been great.
That kind of place.
And then sometimes we get surprised at events, like you remember Longwood a few years ago?
Yeah, like,
Oh my God.
100 people.
Oh my God. We thought it was gonna be kind of a nice, kind of relaxed event. They had other events going on during that time. We were mobbed. There was no, even if we tried to coordinate it, there was no way we're gonna be able to have it.
What about Friday Night Lights? That would be a good one, wouldn't it?
Well,
That's kind of nice because
that's a real big thing.
it's a big thing, but it's kind of nice because there's a distraction somewhere else.
There's a band playing over there in the field.
There's a band, it's like, okay, we're not this, and not, everybody's not looking at us.
And you have to get buy-in from all the clubs to do that.
Yeah.
because the youth clubs are participating.
Right.
Somehow.
So you have,
Sometimes more.
What kind of activities are you guys planning for the eclipse viewing things at the two parks locally here?
Roger? What are you planning at the Eclipse Park, Eclipse viewing?
Well, it depends on how many people we have. I'm gonna bring out the spectroscope, because it's always kind of nice to look at the corona and see the difference. I have the HA, but that's a one-person viewing.
You're gonna bring the white light
A
too?
white light on a camera with a monitor. So groups of people could see that, but it's, 27 inches.
Right.
So, in Madras, we had hundreds of people just standing there looking at our monitor, but then we also had, the thing in the sky go like that too. It also depends on the quality of the sky. They're talking about thunderstorms that day, so.
Yeah.
Right now, Linda will be running the 80 millimeter with a white light on the monitor. I'll be running the HA and the spectroscope. And
How about any of your table materials? Can you bring that?
oh, I've got 4 tables of, information about the sun, about, what an eclipse is. And then a dedicated table on spectroscopy and, what we look for, how to look and, that kind of thing.
Right.
Is that
So,
a guardian?
And that's basically self-directed, which is great. You don't have somebody there. They said, I think they're gonna bring glasses. The Chester County people, said they bring glasses, so I don't think I need to bring any now.
Is that Hyperion?
But basically, right now, I've got 3 instruments and 2 people, so.
Yeah.
Well, I'll be there.
Roger and I,
And I'll bring along my Upton Solar 60. That's set up. And I also have an 80 that I live on White Lake.
We have 2 events a day?
we have only one event that day, I think, right? And we have a second one you and I are doing at Exton Library.
Yeah.
That's a week before.
Okay, that's not on the day.
No,
There's only one event a day.
yeah, we're just building up
Only one
interest.
of them.
Just the one
No,
event
I'm not muted.
Oh, at Hibernia.
at Hibernia, yes.
Not, I got you saying, I thought I saw you.
The Exton one is Roger and I at the Exton Library. They're setting up by the entrance, and basically just grabbing whoever comes by. They also are doing it as adult learning thing, but, I was like, let's set up in front so you can capture everybody coming by and let's look at the scope.
Well, I'm going to Middletown Library, if it doesn't rain, on the, 27 or 28, that Wednesday. I can't think of any other, I'm doing a lot of school events, but people aren't supposed to go to school events, for the security kind of thing. April 6th, I'm gonna be at, Rachel Cole Library.
Okay.
And we're there from 12 to 1, possibly a little bit later if it's a decent day. Well, that's the kicker. It was just that really horrible weather.
Had nothing, right? Does that answer your question?
But anyway, I'll try to make sure Mike has all the dates that I have. And we talked about, anytime you're gonna do a night event, I'll do a day event at the same place. That's a little tough to do at like schools because they're, they let out. But go to Tyler or, we got asked by Longwood to go do the Eclipse event there. But, we were committed to, the library system in Chester County. But
They reached out to me and I'm like, that's not gonna happen. We're having enough trouble just getting people at the one for hours, let alone go do something at Longwood.
Yeah, we're going to get to television. That's the thing.
Exactly.
So.
Well, as someone who's brand new here, I can say, hopefully, unless I'm a total weirdo, I would hope there are people in the community that, don't have the time or the means to travel to the Paso totality, but would still be interested in like taking the half day off to like really make the most of the partial eclipse we're gonna get here, because it's a lot of coverage, like, we're pretty close to the path to totality, right?
Yep.
It's gonna,
We get to 90%.
yeah, that's. I
It's
mean,
a
how
lot.
often do we even get that?
Yeah. You know,
No, it's still light out, but.
Yeah, but if you have the right tools to look at
Yeah.
it, you can make a
Makes
lot of it.
yeah.
I think that time spent like bringing people together at the beginning of the event before it starts, when you're sort of awkwardly standing around, like that's really key to, just bringing the group together, make people feel welcome.
Right.
You said that, but I think that was right on. But would make a big difference.
I think it would. Again, Don's point's right. We just need to organize it is the challenge. Any volunteers? How about people coming out in this room? Everybody interested? Yeah. So that would be a big start. I know you'll be there, Pete.
Well, just to,
At least you guys are gonna get to see it. Here in Florida, I don't think
I know we have.
Yeah, you won't see it. What's your coverage?
I'm not sure. I never really looked. I thought we were just too far away.
Yeah, I think it won't be great for you.
No. Mm-mm. It'll be something. It'll look like a bite taken out, but I don't think it'll change the light in the sky at all.
It'll look like a new moon. No, it's a very thin sliver. I mean, 90% of the sun is covered up. So we're gonna see a pretty good eclipse.
It'd be a pretty dramatic look. Okay, it won't be, it'll be light.
It'll get dark.
Not in Florida.
It's different than a total, but.
Right.
It's pretty close.
Yeah, I told Longwood because if all the leaves and stuff, they're gonna have projections of the eclipse on the ground. Make sure you got photographers going around, taking pictures of that around Longwood.
In 2017, I wasn't involved in astronomy at all, but the job I had at the time, somebody went out in the parking lot with a phone.
That's exactly it. Call to, even your fingers, you do it. You do this, that works.
I'm seeing every student in the school.
He's great. And so, I guess to bring closure to this, sounds like we've got interest in at least considering some changes, to how we do things. Not try it on every event. Pick a few events this year to try it on. I think we'll have to have a discussion which events those are. I'm willing to try to help organize some of this. Okay, so if no one else volunteer, I guess I'll volunteer to do that.
I think that what I'd like to do is, if it's possible, after the eclipse, I think we need to get one of our meetings together. When, yeah, when you attend the class, and check in.
Is there food?
Always.
Well, you definitely have to wait for the better weather. This weather is better.
Well, the actual truth of the matter is, half of our events get cloud or radio.
Yeah.
It's, if we're doing 50%, we're doing.
Well, 26 weekends went with toilet wet.
Oh,
You just couldn't see it, and then the other days too cold, you know? So,
I mean,
very few events.
a lot of us went up to Cherry Springs and just.
That's why I like solar stuff. Yeah.
But I think that Don's right. I think that there are some avenues that we can explore, things that we can do technically in the field. I mean, my wife and I tried to see what we could do just using phone, cell phone holders on an eyepiece in a small scope.
Right.
Because we figured that would be and just to try to quickly adapt everybody's different cell phone to that eyepiece. It was nuts. That's why I'm saying, thank God for the C-Star. Because, we tried it, just the two of us, and it really was a three or four person assembly line necessary in order to be able to get kids quickly with the scope, take a picture and then move back.
Right.
The last time we did the solar thing over the Exton Library and so on, there was a surprising number of people that when they came up to my scope, they held their phones and took some pretty good pictures.
You can, again, it's just right. Yeah.
Yeah, I had a lot of people who were doing that.
Great.
Well, one thing, if I can just add to this, the visual aspect. What I was invited by a friend up to a star party in Valley Forge. Not to say you have to go to this extreme, but I was was quite amazed, one person actually brought like, I think it was like a 50-inch flat screen TV, put it on a table. He was actually doing the electronically assisted astronomy and projecting on the flat screen.
Right.
And that actually drew a huge crowd.
I'll bet a
of
big
people
crowd.
just to view that and everything he was taking pictures of. So I think the Sea Star, even if you could just, a lot of people do astrophotography, if they have a tablet, could just set up and show people pictures that you've taken.
I know someone's done that.
I mean, that's, I think, and especially too, it seemed like the younger people who were there were gravitating just to that picture. They go through the scope, but when it was on the television or,
That's what folks do on the, the eyepiece is nice and stuff, but if there's something that's, electronic media of some sort, that's what they drive. And that's why I think the C-Star may be the future.
Yeah, we need a big screen to project on.
Wasn't part of the beauty of the C-Star is literally to see it on the top.
Well, on one person. The person that has a screen. You can't network now. Because you have to have the C-Star app installed and connected to the scope, and you can't connect to them. But I have an iPad Pro, it's about that big square. That works great.
Okay.
Have that little stand I made for it.
There is a mode that if you set it up, you can project to, that you can connect to a TV.
Yeah.
I haven't done it. Have you done that? I know the mode exists.
I think that there is a way to do that.
I think
As
there is.
long as,
Yeah, that's what we do. We have a camera on the telescope. The camera projects to the computer and that projects onto the monitor.
Right.
And when we were at Kenneth the other night, I had that monitor, well, I was running a loop because we weren't outside. So I was running a loop and, 300 people came by and looked at our TV, a little small thing, but that's all I could carry, a mold. So, a great big one would be I don't need a lot of power to run a 35-inch monitor. I just can't carry it.
Right. I wonder how they powered the 50-incher.
Well, you had a disc, I couldn't believe how much equipment you had just to do that. I mean, he had a generator.
Wow.
3 tables, and it was quite a setup.
That's impressive.
Was that at the monitor playing field?
That was pretty extreme, but.
Yeah, that's why I had to look for an outlet.
It
Yeah.
definitely attracted the crowd.
I'll bet.
The DVAH, Delaware Valley Energy Fund.
Yeah, that's what.
Yeah, they do it big.
Yeah, my friend lives up in Chester.
Yeah.
Yeah.
DVA, they do a lot of stuff like that.
Yeah, I couldn't believe it when I saw it.
They have amazing participation. Amazing.
And we can get there, just slowly but surely. Come out.
but I think the first thing we need to do is find out who's got what gear, and then,
I think that a survey is a great idea.
I think that falls on.
And then Dave, you're proposing an open kind of meeting after one of our executive meetings?
Or as part of the executive meeting. Yeah, I've always, as long as I've been present, for the very few meetings that we've had, because so much was hamstrung by COVID.
Yeah.
But, I've always opened meetings that interested parties, spouses, whoever wants to show up and participate as well.
I'll be happy to come to discuss this if you guys want.
It is after the eclipse in April, perhaps after the meeting, or perhaps early. All right, I'll start getting the schedule out.
I mean, does anybody want this deck? We could send it out, it has links and stuff in it. We could send it out to you guys. And so you can think about the material, some of the links, see what you think, come up with other ideas. This is meant to just stimulate discussion, guys.
Okay.
I can make that into a PDF and send it to everybody.
If you would, please. Thank you.
Sure, that's easy to do.
Well, thanks, Don, for putting it together.
No problem. Thank you, Don, for your help.
All right.
Don one.
We're the Don.
I'm gonna shut down the,
Yeah.
Zoom.
I think you don't need me anymore.
We had a lot of stuff in my car to give to you. All right, bye, everybody.
Good night,
everybody.
Bye.
See ya.